Safety-sensitive work carries a specific risk of impairment that can occur without the presence of any foreign substance. We can measure this risk through the physiological state of prolonged wakefulness, which maps mathematically to equivalent blood alcohol concentrations. This coordinate plane plots a standard blood alcohol concentration curve. Risk is tracked against specific regulatory markers, like the Department of Transportation's .04 violation threshold and the .08 national legal driving limit. 17 hours of continuous wakefulness produces impairment equivalent to a .05 BAC, exceeding the DOT violation threshold. 20 hours brings that equivalent to .08, and 24 hours pushes it to .10, which is above the legal limit in every state. These metrics mean a driver can reach functional impairment identical to a DOT violation without consuming a single drink. Time awake alone creates this condition. Fatigue and stress function as quantifiable biomechanical states that systematically degrade executive function and activate the exact neurological pathways responsible for substance relapse. The biological failure point is the prefrontal cortex. This region, the brain's executive control center, is uniquely vulnerable to sleep deprivation. As fatigue accumulates, working memory degrades. This causes the vigilance required for transportation work, the ability to sustain attention over long periods, to fail. This process creates a self-assessment problem. The neural system responsible for evaluating performance is the exact system being degraded by the exhaustion. This culminates in a microsleep, a brief, involuntary episode of unconsciousness that occurs without warning and without the driver being aware it happened. At highway speeds, a 4-second microsleep is functionally equivalent to driving the entire length of a football field while blind. While a single night of poor sleep is recoverable, cumulative fatigue involves the gradual accumulation of sleep debt across multiple days or weeks. Occupational conditions in transportation, such as overnight hauls, sleeper berths, and irregular starts, systematically generate this debt. After one night of reduced sleep, subjective sleepiness plateaus. A driver feels no more tired than the day before, even as actual cognitive performance plunges. This creates an invisible gap between how capable they feel and how impaired they are. Their judgment system has flatlined. Federal hours of service regulations exist because these occupational conditions produce this widening gap of impairment, regardless of a driver's individual intent. Stress operates through similar biological channels. Acute stress is an adaptive, short-burst mechanism that sharpens focus to meet an immediate challenge. To achieve this, the brain releases a neurochemical payload, including cortisol, adrenaline, and corticotropin releasing factor, or CRF. Chronic stress occurs when this chemistry is sustained or activated repeatedly without recovery. The CRF signaling pathway stays continuously illuminated, never returning to baseline. Sustained exposure to these chemicals leads to impaired working memory, reduced cognitive flexibility, and increased impulsivity. This elevated chemistry essentially produces the same cluster of cognitive impairments as substance intoxication, but generated entirely from within the brain. The activation of the CRF system links chronic occupational stress directly to the mechanics of dependency. The CRF pathway physically intersects with the brain structures responsible for drug-seeking behavior, specifically binding to the reward pathway. Under chronic stress, this system becomes sensitized, causing the brain to respond much more strongly to everyday stressors over time. For individuals with a history of dependency, this sensitized reward system increases craving and drives a return to substance use as a learned behavioral response. Occupational stress acts as a documented biological trigger, reactivating learned patterns exactly when the cognitive control needed to overwrite them is at its absolute weakest. Relapse is a gradual process that begins long before physical use. Stage 1 is emotional relapse. The individual experiences rising anxiety, irritability, and poor sleep. Cumulative fatigue and chronic CRF activation pour into this stage, causing the funnel to swell. This leads to stage 2, mental relapse. In this phase of conscious internal conflict, the biological pull of the CRF system becomes an active craving. Stage 3 is physical relapse. The return to use occurs only after cognitive defenses have been thoroughly eroded by the first two stages. Recognizing stage 1 symptoms like irritability or sleep loss is critical. This biological cascade is exceptionally difficult to interrupt once it reaches the later stages. Fatigue and stress compound. Fatigue destroys resources needed to handle stress, while elevated stress chemistry disrupts sleep. Establishing 7 to 9 hours of sleep is a non-negotiable intervention. It allows the brain to clear waste and regulate the stress response, breaking the feedback loop. Physical movement provides a second intervention point by reducing cortisol levels and engaging the reward system through natural dopamine production. Setting strict boundaries around off-duty time is also a biological requirement. The brain's stress response cannot reset if rest periods still feel like work obligations. Utilizing structural support like employee assistance programs or peer support provides the most effective interruption for stage 1 emotional relapse, acting before a crisis point. Federal regulations address fatigue with the same seriousness as intoxication because the cognitive failure is structurally identical. Managing sleep and stress is an operational mandate to control these biological relapse pathways.